Hey guys, today's video is going to be more learning about factoring trinomials. Last week we learned how to factor trinomials when a was equal to 1. Today we're going to focus when a is greater than 1. And this video is going to be looking at a method called the split method. There's also going to be another video, it's an unofficial name, but we call it the lazy man method. This split method is definitely the most traditional way by far. It's what I use throughout all of my schooling, and I think what most of your teachers will use moving forward. So we're going to focus on this one, but there will be another one just to check out in case you liked that way better. So for the split method, we need to use this split method when a is not 1 anymore. So on top I have an example here. When a was 1, we were able to just jump into our x puzzle and put our constant term on top. So in this top example, c would be 10, and the b would be 7. And we were able to figure out what multiplied to c and added to b. Well, starting today, we're introducing when a is greater than 1. So for example, 6 in this equation. So when we have a coefficient out front, a leading coefficient that is not 1, we need to do something a little bit different with our x. And for this, we're going to do a times c on top. We need to account for that leading coefficient that is no longer a 1. So we're going to multiply a times c on top. We're going to keep b for our bottom still. So we're just going to jump into that first example now. And we are just going to get going over here. I noticed right away this is not 1, so I'm going to need to use my split method. For my x, when I set it up, I'm doing 6 times 2 on top. So when I do 6 times 2 on the top, I'm left with 12 for the top of my x. And on bottom, still b for bottom, so I have negative 13. Now I'm looking for what two factors multiply to 12, but also add to negative 13. So I know right away, if you didn't, you can list off on the side the different factors for 12. I know it's going to be 1 and 12, but I need them to add to a negative number and multiply to a positive number. So here I'm going to make them both negative. Negative 1 times negative 12 is positive 12. Negative 1 times negative 1 plus negative 12 is negative 13. So this next step is why this is called the split method. I'm going to rewrite this trinomial, and instead of writing negative 13s, I'm not going to use that. I'm going to use the factors that I chose that work for this problem. So watch here, I'm going to do 6s squared. That's just normal. I am not writing negative 13s. I'm going to replace that with these two factors. And it does not matter which order you put it in. You could put the negative 1 first or the negative 12 first. And those are both s terms. So I'm going to say minus 1s, minus 12s, and then I have back to the plus 2. So all I did here, this step is just rewriting that middle term. Negative 12 plus negative 1 does equal negative 13. And now I'm splitting that. So I have two separate, I guess you can think of it like I have two separate chunks. I need to pull the GCF out of each of those chunks. That's my next step. So if I'm looking at this front part out here, there really isn't, well, we have an S. We could call S the GCF. And if I pull S out of this front term, I'm left with 6S. And if I pull S out of this term, this green one, I'm left with minus 1. Next, I have the second chunk that I'm dealing with. And with this, there's a little bit more. I need to pay a little bit closer attention. I need what's left over to be the same as this. It needs to be the same. So what can I pull out of this chunk to make this also 6s minus 1 left over? Well, I could pull out a negative 2. When I pull negative 2 out of negative 12s, I'm left with 6s. And when I pull negative 2 out of 2, I'm left with minus 1. Notice how these are the same. That's what I was talking about. Those are the same. And after I do that split, I now have two binomials that are going to be factors that would FOIL back to this original trinomial. And I'm going to use this first term out here, s, and this first one out here, minus 2. That's going to create my new binomial. And the next binomial is what I have a double of. So 6s minus 1. And you would be done. You factored that. If you FOILed it back out, you would end up with 6s minus 13s plus 2. So this is your factored form of that trinomial. Now I know that's a lot. It's a lot of steps to take in, especially on a video. So we're going to do 2 more examples. You continue to watch them and take it in. If you didn't get it on that first one, that's okay. We have 2 more, and we have also 2 try it on your own. So this next one, I have 5a squared plus 13a minus 6. First step, as always, is going to be to make an x. I'm going to do my x puzzle. And with this x puzzle, my top is a times c. So 5 times negative 6 is negative 30. And my bottom is still b, so that's 13. Now I'm looking for 2 factors that multiply to negative 30 but add to 13. Let's just go through those as a reminder. 1 and 30, those won't work. 2 and 15, those will work right away. So 2 and 15 I'm going to use. Now I need to make the top negative but the bottom positive. Therefore I know I need to have a negative 2 out in front. Negative 2 times 15 does equal negative 30. Negative 2 plus 15 does equal 13. Now I'm going to do the split part of my factor. So here I'm going to split this middle term. I'm not going to write 13a. I'm going to write 13a using negative 2 and 15. So just to show you that it doesn't matter where you put them, I'm going to actually flip-flop this. I'm going to write 15 first. It does not matter what order you put them in. Plus 15a minus 2a minus 6. And for this, again, guys, I used these 2 factors, negative 2 and 15. I used those here instead of writing 13a. 15 minus 2 does equal 13. Here's where I split. I'm splitting it right down the middle, so I have 2 terms on each side of my split. And I'm going to pull out the GCF on either side, leaving me with the same binomial. So first over here, I see right away I can pull out a 5a for my GCF. And when I pull out a 5a, I'm left with a plus 3. Over here, I need to pull out something that's going to make my leftover binomial match a plus 3. So I know I need to pull out a negative number. I'm going to pull out negative 2. When I pull out negative 2, I'm left with positive a plus 3, which is what we wanted. We needed these 2 to match. And the 2 binomials that are going to multiply together to create this original trinomial, we're going to use those 2 GCFs we pulled out. So 5a minus 2. And my matching one, a plus 3. And you would be done. You factored there. You can go ahead at home and try to FOIL it. Make sure it multiplies back out to this. We have one more example of factoring when a is greater than 1. This time my a is 2. It's still not 1, so I need to use my split method. On top, remember I'm doing a times c, so 2 times negative 1 is negative 2. And b for bottom, there's really an invisible 1 in there. I'm going to put a 1 down here as well. So my factors here obviously just have to be 2 and 1. I need it to multiply to a negative and add to a positive. So I'm going to make my 1 a negative. 2 times negative 1 is negative 2. 2 plus negative 1 is positive 1. So I'm going to rewrite at this point. And I'm rewriting using these 2 terms instead of 1b. So I'm going to rewrite 2b squared. I'm not writing 1b. I'm going to write plus 2b minus 1b. And I carry on with my minus 1 at the end, my constant. So here I notice that 2 minus 1 does equal 1, so I did that correctly. Here's where I split. That's where the name comes from. Split right down the middle. And I'm pulling out a GCF on each side that's going to leave me with the same binomial. So over here, I'm going to pull a GCF out. I see I have a 2b that can come out. When I pull 2b out, I'm left with b plus 1. Over here, now I need this to match whatever I pull out over here. So I know I need to pull out a negative number. If I pull out negative 1, I'm left with b plus 1 on the inside, which is what I wanted. Those are matching. My resulting binomials that multiply together to this original trinomial are going to be my GCFs, so 2b minus 1 and b plus 1. So next, guys, I'm going to have you try 2 on your own. If you're following along with the notes, we're actually going to skip that middle example. The leading coefficient in that is negative 1, and the reason why we're skipping it today is because later next week we're going to figure out a way easier way to solve a problem like that. So I didn't want you guys to get stuck on this method for today for that one. So for the 2 try problems, we're going to do the one on the bottom left and the bottom right. If you don't have the notes, you can copy this one down in yellow. 2w squared plus 7w plus 3. And then the one on the bottom right, up in green here, I have 3y squared plus 5y plus 2. So you guys can pause your video at home now, try those two on your own. And here are the answers, one in yellow. For our yellow trinomial, I end up with 2w plus 1 and w plus 3. If you did not get that, make sure you pause it and check out what I did compared to what you did. Remember, finding your mistake is almost better than getting it right the first time. And now the one in green, I end up with 3y plus 2 times y plus 1.